Well, what are we up to today? Well, we're going to be playing with some dangerous stuff. I have a boiling vessel from a Centurion tank, and I have a modern version as well, but the thermostat, through some unfortunate mishaps, has blown its thermostat to pieces, and I'd like to replace it. But when I've gone to remove the cover off it, I found out that it's full of asbestos. So we're going to have to do some careful work here and some preparation to make sure we don't contaminate things with asbestos and don't condemn myself to asbestosis in 20 years time. Fortunately, somebody has donated some little thermal overloads here, which I think will work nicely for a thermostat. These are basically just a bimetallic strip in a can. I think they'll work quite well. So these were donated. I need to test if they work first. So before we get into the nitty-gritty stuff, let's check if these work. Our setup here, we've got a bit of blue tack. We have a thermal overload set here. We have a 90 and a 95 degree one. So we're going to test our 90 degree one first. I'm going to turn on my beeper, which you'll hear beeping. I have a thermometer here. We're going to heat this with a stoner torch gently from a distance till it stops. That's just gone click and it stopped. I'll check what temperature it is at the top, although it's hard to measure this with this particular infrared temperature probe. It still says only about 30 degrees. It's clearly hotter than that. So we'll give this a couple of minutes and it should go click and return to normal temperature and turn back on. We can probably accelerate the process by putting something cold against it and wicking away some of that heat. There we go, it's just clicked back on again. See, it's working. Let's see if the 95 degree one works. Our 95 degree one, and it's beeping. Let's see if this one will reset. Should click at some point if it works. Sometimes these rings fall forward. There we go, it just clicked. Sometimes these rings fall forward and short out the terminals. You have to be careful. Let's just touch this one for a bit. Something cool. See if it helps cool it off. I'll give it a couple of moments. There we go. It's just reset. So 95 degree one works well. Considering we're boiling water, that's probably the one I'm going to go with, being that if you're not in a country that uses metric, water boils at 100 degrees Celsius, so that will be about right. Alright, let's see what else we can do with this project. Alright, so we're outside now, actually in the back of the ambulance that we'll be using this in. This is our boiling vessel, and this is a modern version. This has the thermostat and some smarts all built into it. You just need to give it power. This particular model, we have heating element on these two pins and a thermostat on those two pins. That's it. It's designed to work with an off-board relay, which I have installed down here. It's a solid state 100 amp relay. Before I knew what was going on with this, and before I had circuit diagrams, I measured all the impedance here, and I got about 2 ohms across these pins, and I got 2 ohms across these pins. And I thought, great, we've probably got 2 heating elements. And that was further confirmed when I got the cable in, which has huge big copper cables on all 4 of those pins. I now know that's just for consistency's sake. So I paralleled these up. And ended up a little puff of smoke came out, which I think was the thermostat dying. But when I opened up the bottom to have a look, it was full of what looked suspiciously like asbestos. So I closed it back up, not wanting to screw around with things. I did take this cover off here to have a look at what's on there, but there's so much asbestos there I can't tell what it's connected to. So I then noticed that there's a rubber seal around the placard here. And I've since discovered that beneath that is access to what I think is the thermostat. The heating elements I would expect to be underneath. The thermostat I think would be on the side. Now this has got 180 degrees Celsius thermostat cutout, which is great if it's boiling over and you don't want it to die. that's great. The new one has something similar. It's got 175 degree cutout with 180 degree thermal fuse that's non-replaceable. So that's boil over protection. I'd rather this self-regulate itself. So I'm thinking if I take this off and I'm real careful and I put a mask on and I stay outside and I keep things moist, I can probably safely get into the thermostat and replace it with one of these little things. But I've got my little microscope out here. I want to take a small sample of this and stick it under the microscope, see if we can get an idea of what it actually is. That could be a little difficult without contaminating things, because I'll have to transport asbestos somewhere in some way. So we'll see how we go about that. I might be able to adhere it to a little bit of blue tack so that it stays stable. In either case, I've got to do some thinking, but yeah, at some point fairly soon we'll pull that cover off. I've decided I'm going to take this cap off, and good thing about COVID era is surgical masks are easy to find. Now I know these aren't the greatest for particulates, but I'd hope they're going to slow down a little bit what I'm doing. So if I sound a bit funny, it's because I'm trying to cover my mouth a little bit. Now I have some screwdrivers kicking around somewhere right below me. Let's have a look here. I need a bladed screwdriver roughly this size. What we're doing at the moment, we're just going to take a small sample that I'm going to adhere to some blue tack and stick it under the microscope. So we can get this guy open. Let's be a little careful here. Now I have checked under this before, so the rubber seal is largely separated, but it is a little adhesive. Right, so this is pretty much what we suspect is asbestos. I'm going to take a few fibres off here and stick them down under the microscope. I'll have a look at what we have. Right, that should give you enough to take a look at first. Oh yay, just dropped one of those Whitworth screws in the grass. Yay. I'll screw this down loosely and then we'll have a look under the microscope. Alright, so like I said in that clip before, it's pretty hard to tell what I've got without polarized light. But based on that little sample there, it's not behaving like fiberglass. Fiberglass has got a lot more flex to it. This is actually pretty brittle, and it doesn't look very transparent at all, so I'd say it doesn't look at all like ceramic stuff either, so I'd say it's more than definitely asbestos. So we want to be real careful here. Now, it's at this point where we're reasonably sure we have asbestos that I've got to tell you guys, just don't do this, okay? It's just so much easier, just don't do it. I'm only doing this because I'm a little bit crazy. You really don't want this stuff in your lungs. You won't find out for 20 years or more if you've got mesothelioma or asbestosis. It's just really not nice. I have multiple sclerosis, so my future is uncertain anyway. I don't really want to complicate that with asbestosis, so I'm taking some precautions. But anyway, I'm going to use a little bit of spray adhesive to stabilize this, and I'll be doing that probably off camera in a minute. I'm also not sure if this thing's been leaking. If it's been leaking, that's pretty much a deal breaker. In any case, let's try and get some of this stuff out and into a bag and stabilize so it's not blowing around the place. Improvised glove. We have some of it removed and bagged very carefully after stabilizing it, so that we didn't get any fibers loose. I've stabilized as much in here as I can, but I've only removed as much as is necessary. So let's bring the camera over here so we can see what we're doing. We're looking at the top of it. I'm going to put my meter up here, and this should beep when we get continuity. And our thermostat appears to be closed. So I'm not sure if that's our heating coil or what, but fortunately I have plugged the lead in so that I can determine which is which. Now according to this, the grey should be our thermostat connection. Alright, let's have a look here. Nope. Alright, so we've got thermostat connections there, but we're open circuit on the other wire. It might have blown off a fuse or blown off on the back of the plug. So that might have kiboshed these plans right away. So give me a moment to think. I think for the moment, I'm going to have to undo another cover. So I think for the moment, we're going to cover this thing back up again, just to stop any loose fibers getting out. And we'll have a look under the actual connection and see if I've blown a wire off there. Because I do recall when it gave its little puff of smoke, it come out near the connector. So I guess we'll have a look at that and see what it's like in there. We'll seal this bit up first. If it gets much more complicated than that, I'm pretty well going to abandon this and close it up, and I'll use it in its current state. Alright, so what we can do with this side. Pop this up. These are some fine thread screws, these things. Alright. Definitely a windy day. I'm not sure if there's fabric waving in front of the camera or not. I can't tell. And I'm not sure how bad the quality of the audio will be with all the wind. I really should have taken my projection screen down before I did this, but that happens. Need to find a spot under here where I can lift. Alright. So, as expected, it's packed in. Oh, okay. Let's give a close-up look at this. Let's come around here. It's all packed in with some form of silastic. Yeah, okay. I think at this point, it's just going to get used as is. I'll figure out some other way to do the thermostat. Which means I can probably rip that whole relay out, because I just don't need it now. Which is unfortunate. But yeah, there's a wire has blown off inside somewhere. I'll have a little bit more of an explore around the thermostat area, but I don't think that's going to be easily repairable. But I do know a bloke that might swap this over for a functioning one. But again, at 185 degrees, it doesn't really matter anyway. So, all right. Let's have another look. Alright, so I'm having a bit of a probe around here to see where these wires go, and they just disappear off into a tremendous block of asbestos. Given the thickness of those wires, I can certainly envisage that they might have blown off. That one there looks a little unreliable, but it's certainly connected. It's more trouble than it's worth at this point. Sometimes you can't fix everything. Sorry for the wind, guys, but I took another look and I realized quite by coincidence that one of the wires here had actually gone to ground, and no other wires in this circuit go to ground, which is nice because it means I can use the remaining wire on the thermostat to ground it out, and I can carry it back through to that pin. A nifty little trick, and probably saved by the wonderful insulating properties of asbestos, but not something you'd do every day. I haven't soldered anything in here. I've just wedged this thermostat in, because the consequences of this going wrong are pretty low. If it goes dead short to anything including ground, it's going to turn the thermostat on. If it goes open circuit, it's going to turn the thermostat off. So chances to mess this up are pretty slim. So we're going to pack all the stuff back in here again. and that will be the last ever time we shut this up. I hope this works. It's in there fairly well. I guess we'll see what happens. Right, so the mod is complete, thankfully. We have the old thermostat here, which I'm surprised to see that the contacts weren't welded shut. But at 180 degrees, that's still way too high for me. So, and there's a little mica shield. It was an insulator here, that's come out as well. But I'll keep that for posterity. Now, we have our main supply cable here. We have our thermostat cable here. About to do a test run. We've got water just below the 2 pint mark. So we'll see if that boils. But crucially, I'm going to have to start the engine on here to get the alternator running. I'm down to about 25 volts. And I'm only putting about 4 amps in from solar. Largely because we camped in this last night and ran the projector all night. So let's get the alternator running and get a bit of charge in. Alright, let's take our key. It's a bit of a windy, overcast day today. We'll let things idle a bit. Now I'm not sure if the shunt for the 24 volt system is actually connected. Now we're going to get things idling just a bit to get a bit of oil pressure up in the turbo. It actually mentions that up here, but it's a pretty standard thing for all turbos. You know, run for 5 or 10 seconds first. That should be about past by now. I'm going to see if this moves. Let's bring this up a bit. We'll just bring our revs up a little bit so we actually run something on the alternator. Alright, let's go around and see what our voltage is doing now. Alright, so it says we're pulling 9.5 amps, but I know this shunt's a little bit wacky, so it could be that it's putting about 20 amps back in the batteries. We'll see what happens once we run the boiling vessel. What I'm going to do first, I'm going to unplug the thermostat connection. I'm going to turn on our isolation switch. Now there should be a little light should come on in here when we plug these two leads together. Yep, the light come on and the engine revs dropped. So I think we're heating up. Let me go and see what we're pulling now. Now this current meter is not great at determining whether I'm pushing or pulling current. Reckons about 6 amps. I reckon we're putting about 40 amps in. Let's get my clamp meter out. Find my clamp meter here. We'll go to our, I think 400 amp range is what I've got to do here. And we'll pick one of our power leads here, probably the positive. So it reckons 49 amps are what we're pulling on that. If we can see it in the camera there, 49 or so amps. I reckons it's rated for like 55. So that shouldn't be too bad. It is warming up. Been running for a couple of minutes. We'll see what happens. Actually, what we can do, you guys might notice this. This is the thermostat one. If I hear the engine revs change, we'll turn the thermostat back on. There is a slightly noticeable drop in engine revs when we turn the thing on. Anyway, let's see how she goes when it boils. Right, so it's been a few minutes and we're watching the water temp come up. It's coming up to about 90 degrees. I wonder if it's going to boil, although this thermostat probe's probably sitting right on the bottom. We'll find out. Let's give it a few minutes. So it reckons the water is hovering around 90 degrees, and I'd believe it in there at the moment. She's certainly getting hot. So at some point that'll probably kick out. We're just waiting on our little light to come off, to turn off here, which, can we see? Yeah, our light is still on. Anyway, I'm going to wait until that turns off. Well, we have a rolling boiler happening at the moment. She's boiling quite nicely. Has our thermostat kicked off yet? I can't quite tell. I think maybe. I'll give it a few more minutes, see what happens. It's absolutely boiling its tits off right now. And it's doing a really good job. I think maybe I need to have the water level a smidgen higher, although the thermostat is about here, right where the top of that water level should be. So, I don't know. It hasn't kicked out yet. I'm going to give it just a tiny bit longer, and otherwise I'm just going to concede defeat. Do a quick temperature probe. I'm going to chuck it in the steam vent at the top here. which is exactly 100. Let's chuck it into the water vessel at the bottom. Ow, I nearly burnt my finger there. She's a little over 100, so I think it's probably safe to say that the thermostat, if it's making proper contact, probably hit 95 degrees at some point there. We'll have a quick look. Can't really tell down there. Our light is still on, but look, I'm pretty confident it would kick out. I may at some point chuck a different thermostat in there that's a lower temperature, but for now I know it works. I'm going to unplug our thermostat. There's our revs come up. I'm going to let it run for a bit and see what can be done from there. So while we're running, I've got the leftover of my apprentice's hot chocolate from last night. I'm going to use some of this nice blistering hot water to rinse out the hot chocolate cup and get rid of the excess chocolate out of here. So yeah, this one gets it much hotter much more quickly, so that's pretty good. One thing I did find out is there are actually refractory bricks underneath the bottom of the heating vessel too, around the heating elements, which is a nice thing to see. Anyway, I'm going to let this one cool off, which is probably going to take the next 6 hours, so I'll see what my battery volts are doing, but I'm pretty sure this one's going to be the actual end of the video. So anyway, I hope you've had fun. This is really the end of the video. I don't know if I've got success yet, but the pinout does now work as intended, so we're better off than when we started. Anyway, I don't want to play with asbestos again, so I'm going to leave the plates on this. If it works, it works. If it doesn't, it doesn't. I think it'd probably hit 95 degrees before it melts, so it would probably shut off. So from that perspective, the boil over protection and anti-fire system will work. It's not likely to burn out the back of the camper. So on that note, we'll see you later, and hope you had fun in the next one.